Today we're going to be using the coordinate plane to decide what type of quadrilateral a certain four-sided figure is. And we're going to need, and we might even work with some triangles. So we're going to need to go back and use some of our coordinate plane tools that maybe we've forgotten. Distance formula, if you need to determine whether sides are congruent or diagonals are congruent, the distance formula is a really good thing to use because it'll tell you how long a segment is. If you're trying to decide whether or not diagonals bisect each other, and why would you need to know that? If you want to decide if something's a parallelogram, its diagonals bisect, you'd use the midpoint formula. So if I find the midpoint of two lines, and that midpoint ends up being the same number for both lines, those lines bisect each other. That's really good in using a quick way to decide if something's a parallelogram. And then finally, the slope formula. Why would we need to know the slope? Well, if two lines have the same slope, then they're parallel, right? And if two lines have a product whose slopes are a product equals -1, then they're perpendicular. So a slope's product that comes out to be -1, those two lines are going to be perpendicular. When the slopes are the same, those two lines are going to be parallel. Why is that useful? Well, if I can determine both pairs of opposite sides parallel, it's a parallelogram. If I can determine that the diagonals are perpendicular, it could be a rhombus or an isosceles trapezoid. It just is another tool to help classify. So does everybody remember the distance formula, midpoint formula, and slope formula? All right. So let's apply these. So in this particular problem right here, I'm asked to classify this triangle. I want to classify whether it's scalene, isosceles, or equilateral. Okay, so to do that, I'm going to just find the lengths of all the sides. I can't think of any quicker way to do that. So I need to know the length of AB, I need to know the length of BC, and I need to know the length of AC. So I'm going to just plug that into the distance formula. I'm not going to rewrite the distance formula. I'm just going to plug the numbers in. So AB would be 4 minus 0 squared plus 4 minus 1 squared. And that's going to equal the square root of 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. 16 plus 9 is 25. I know the square root of 25 simplifies down into the square root of 50. We're not going to worry about simplifying radicals in this chapter. We'll do that in chapter 8. So I'm going to just leave it like this for right now. And then BC is going to be 7 minus 4 squared plus 0 minus 4 squared. So that 7 minus 4 is 3. 3 squared is 9. 0 minus 4 is -4. -4 squared is 16. That is also the square root of 25. So at this point, I know it's at least not scalene. And then finally, finding the length of AC, I'm going to do 7 minus 0 squared plus 0 minus 1 squared. And that's going to give me the square root of 7 minus 0 is 7 squared is 49. -1 squared is 1. So that's the square root of 50. So two of the three sides are the same length. What type of triangle do you think that is? It's an isosceles triangle. Everybody okay with that? Good. Now you do one. Make it a little bit bigger and easier to read. All right, so to solve this particular problem, what you want to do is you want to find the length of DE. In this case, the length of DE will be 1 minus 0 squared plus 4 minus 0. So that's going to be the square root of 1 plus 16, which is the square root of 17. Then you want to find the length of EF, which is the square root of 5 minus 1 plus the square root of 2 minus 4. So 5 minus 1 is 4, 4 squared is 16, 2 minus 4 is negative 2, negative 2 squared is 4, so that leaves you with the square root of 20. Once again, I'm not worried about simplifying these. And then DF is equal to the square root of 5 minus 0 squared plus 2 minus 0. So that's equal to the square root of 25 plus 4, which is the square root of 29. None of them match, so I would say that it is scaling. Everybody okay with that? Yeah. All right. So that was pretty simple and pretty straightforward. We just had to go through and figure out whether or not a triangle with scalene isosceles or equilateral. There was really no other way to do it. You just find the sides. Now let's look at a different type of problem. Is ABCD a rhombus? And if it's a rhombus, explain why you think it is, and if it isn't, explain why you think it isn't. Well, there's a bunch of different ways to decide if something's a rhombus. If it's a parallelogram and the diagonals are perpendicular, it's a rhombus. If it's a parallelogram and the diagonals bisect the vertex angles, it's a rhombus. Now, we don't have any way of finding out vertex angle measures unless they're going to be 90 degrees. So that's definitely not the route to go. If all the sides have the same length, it's a rhombus. So I think that's probably the way I would go at to solve this, is I would just start figuring out if all the sides are the same length. So I'm going to start out by finding the length of side AB. So side AB will equal, I shouldn't have that little thing over the top because I'm finding a length. So segment AB will equal the square root of 0 minus a negative 2, so that's 0 plus 2 squared plus 4 minus 0. So that's going to equal the square root of 2 squared is 2. I'm sorry, 2 squared is 4 plus 4 squared is 16. So that equals to the square root of 20. Once again, I'm not worried about simplifying. Then I'll look at the next side, BC. Okay, so BC is the square root of 4 minus 0 squared plus 5 minus 4. So that's going to equal the square root of 16 plus 1, which is the square root of 17. Well, I already have two sides that aren't the same length. Do I really need to go any further? So is this a rhombus? The answer is no. The reason is all sides are not congruent. Yes? Sure. So that's how I solved that problem.
So if those two were congruent, then you know for sure.
No, if those two are congruent, then I have to go on and check and make sure that this one is congruent and that one's congruent. So I would check them for all. However, no, I'm just going to say you need to check them for all. Yes, sir. You may. No, I'll go ahead and say however. If CD had turned out to be congruent to AB, as well as these two already being congruent, then that would have been enough because these are congruent. No, I still need to find the third one, the fourth one, because I didn't have a way of shortcutting to decide if it was a parallelogram. All right. So what I'm going to let you guys do is I'm going to let you guys do your own question. And this is a two-parter. And it says basically we're going to look at this four-sided figure, and based on its vertices, we are going to decide if it's a rectangle, and then explain why we think it's a rectangle, and then we're going to decide if it's a square. What do you think is the best way to go about solving this? How do you decide if something's a rectangle? Two pairs of opposite sides have to be congruent. That makes it a parallelogram. And then how do you know that it's a rectangle?
9 degrees.
So one of the things we could do is we could find the lengths of all four sides. And then after that, we could find the slopes of all the lines to see if they're perpendicular. So that's one way. And then that would tell us the rectangle. And then, actually, if all the sides were the same length, it would be a square too. So that would actually end up answering both questions. Is there anything that we could do that would be less work? Because I'm kind of lazy. If we start out with the sides and we find that all of the sides are the same length, it's a rhombus. What would take it from being a rhombus to a square? What would be even quicker? What's a special thing about rectangles? Something about their diagonals. So what I think I'm going to do is to do the least amount of work is I think I'm going to go through and I'm just going to find the lengths of all of the sides, and then I'm going to find the lengths of the two diagonals. The lengths of all of the sides will let me define if it's a parallelogram, and it might even wind up being a rhombus out of that. And then if the diagonals are equal, it was a rectangle, and if it was a rectangle and a rhombus, it was a square. All right? Does that make sense what I'm doing?
Wait, what are you doing?
So I'm going to find lengths. And if I find the lengths of all of this figure and all the lengths are the same, that definitely makes it a parallelogram. And then if the diagonals are congruent, that makes it a rectangle.
So how do you know the diagonals?
I'm going to find their lengths too. I'm going to just use the distance formula. So I'm going to find 6 lengths. So lengths. So the first length that I'm going to find is the length mn. And mn will equal to the square root of -1 minus 0 squared plus 4 minus 1 squared. So that's the square root of 1 plus 9. That's equal to the square root of 10. And then I'm going to find Pn. And Pn is 2 minus a -1, so that would be 2 plus 1 squared plus 5 minus 4. So that's equal to square root of 9 plus 1, which is the square root of 10. So it looks like all the sides are probably going to wind up being the same length. Let's see if I'm right there. QP is equal to the square root of 3 minus 2 squared plus 2 minus 5 squared. So that's the square root of 1 squared is 1, -3 squared is 9, 1 plus 9 is once again 10, and then MQ is the last length I have to find. So MQ is 3 minus 0 squared plus 2 minus 1. So that's equal to the square root of 9 plus 1. It's equal to the square root of 10. So I definitely know it's a parallelogram. So it's a parallelogram at least. If I do parallelogram plus congruent diagonals, it's a rectangle, and then since all the sides are already equal, it'll be a square. So I know that it's also at least a rhombus. All right, so now let's take care of the diagonals. The diagonals are MP and NQ. So MP, so that would be 2 minus 0 squared plus 5 minus 1. So that's going to be 2 squared is 4, 4 squared is 16. So that's the square root of 20. And then the other diagonal will be 3 plus 1 plus 2 minus 4. So that's equal to the square root of 16 plus 4. So that's the square root of 20. So parallelogram and congruent diagonals mean yes. And a rhombus plus a rectangle means yes. So yes, it's a rectangle. Yes, it's a square. Yes, ma'am.
Is that little chart you showed us yesterday of like the parallel, like the whatever you showed us, like all the rhombus and all that stuff? Is that in the book?
Yes.
Wait, it is a rectangle and a square?
Yes. It's a rectangle because it was a parallelogram, and I know it's a parallelogram because all of the opposite sides are congruent. That means both pairs of opposite sides are congruent. That's a parallelogram. And the diagonals are congruent. That makes it a rectangle. And then since it's a rectangle and all the sides were the same, that makes it a rhombus. If it's a rectangle and a rhombus, then it's a square. Does that make sense? So just finding out all the sides were congruent isn't enough to know that it's a square, because it could have been just a rhombus. Finding out that the diagonals were congruent was key to finding out that it was a square, as well as a rectangle. Remember, squares are rectangles. Everybody okay with that? All right. Let's try a different figure. A kite is shown at the right. What is the most precise classification of quadrilateral formed by connecting the midpoints of the sides of the kite? Holy cow, look at all the stuff we have to do for this. So the midpoints of the sides of the kite are going to be found by using the midpoints. So I'm going to have to find the midpoint of K. What is that letter? That looks like an I to me. Does that sound right? Okay. The midpoint of Ki is equal to 0, 1, negative 1, negative 2, negative 3, negative 4. So K is negative 4, 0. And I is 0, 1, 2, 3, 4, 0, 4. So the midpoint is going to be negative 2, negative 2. Or negative 2, positive 2. And then the midpoint over here is going to be, this is 4, 5, 6, 7, 8. So halfway is 4. Halfway up to 4 is 2. So 4, 2 is going to be this midpoint. This was negative 2, 2. So the midpoint of IT is equal to 4, 2. And then, of course, this midpoint's right here, and this midpoint's right here. So the other two midpoints, we'll call that midpoint of TE is equal to 4, negative 2, and then the other midpoint of KE is negative 2, negative 2. And so it's going to ask what kind of figure is formed by that. Well, I like that. because this one I'm not going to have to use a whole lot of formula work on because the lines are horizontal and vertical. I can just count. So this distance right here is 1, 2, 3, 4, 5, 6. This is 3. This is 6. This is 3. These lines have undefined slopes. These lines have 0 slopes. So that means they're perpendicular to each other. Yeah, you're right. So opposite sides have the same slope and are congruent. That's a parallelogram. All the angles are 90. What kind of figure is that? Rectangle. That one worked out really good because after finding all those midpoints, then I was able to just look at the picture and count spaces. I didn't have to use the distance formula. Some cases you might have to use the distance formula because if I take this same picture and I skew it a little bit to where the lines aren't all horizontal and vertical, then it becomes a lot more difficult. And you might have to go in and you might have to use formulas to find the values. Everybody understand that? So an isosceles trapezoid has these vertices. What special quadrilateral is formed by connecting the midpoints? So go ahead and do that one real quick. All right, so using this information here, I drew a sketch of the trapezoid, and I went ahead and labeled the midpoints. And so now all I've got to do is find out what's going on with the midpoints here. I think the first thing I'm going to do is I'm going to find the lengths of the midpoints. So I guess I need to label those midpoints. I'm going to call this X, Y, Z, and W. So X, Y would equal the square root of 4 minus 1 squared plus 4 minus 2 squared. And that's going to equal the square root of 3 squared, which is 9, plus 2 squared, which is 4. So that's going to equal the square root of 13. Now, if its opposite side is the same, so I'm going to go ahead and do the opposite side really quick. So that's 7 minus 4 squared plus 2 minus 0 squared, which is also equal to 9 plus 4, which is the square root of 13. So I know that this side right here is congruent to this side right here. Okay. I'm also going to decide if those two lines are parallel. So the slope of xy and the slope of wz can be found by doing 4 minus 2 over 4 minus 1, which is equal to 2/3, and 2 minus 0 over 7 minus 4, which is also equal to 2/3. So these lines are also parallel. So if something is both parallel and congruent, that makes it a what? What kind of figure is both parallel and has one pair of sides both parallel and congruent? Parallelogram. So now I can even decide the slopes of the diagonals. And look, if you look at the slopes of the diagonals, one has an undefined slope and the other has a 0 slope. What does that mean? Perpendicular. So if the slopes are perpendicular, it's a rhombus. If I can find out that the two slopes are the same length, well, this has a length of 1, 2, 3, 4. And I said two slopes, but I meant two diagonals. This has a length of 1, 2, 3, 4, 5, 6. So the diagonals are not congruent, so it's not a rectangle. But the diagonals are perpendicular, so it is a rhombus. That means it can't be a square, so the answer is rhombus. Parallelogram with perpendicular diagonals. There were other ways you could have gone about figuring that out, but that's the base of it. All right, so that's your skill set that you're going to be using Tonight, your homework is off of page 403. You see that you have very few problems, but the problems do have multiple steps. It is very important that you practice this stuff so that you will be prepared for what goes on in class tomorrow.